In this lesson, we're going to talk about finding the inverse of functions with domain restrictions. So we're going to be looking at functions that may not pass the horizontal line test, so we can see how we can use its domain restrictions to find the inverse that is a function. Okay, so we're going to talk about the horizontal line test again, and I'm going to switch over to Desmos. So if I have a function like y equals x squared, okay, I get this purple graph. It passes what we call the vertical line test, and I'm going to switch this to red so that's easy to see. It passes the vertical line test, which means y equals x squared is a function because this red line is only touching the graph at one point. But if I change this to a horizontal line, I see that this line is touching the purple graph at more than one spot, basically everywhere on this graph. So that means that the inverse of this is not a function in its current state. But what I can do is I can apply a domain restriction. So I can add a curly bracket here, and I'm going to type in a restriction like I want all of the x values greater than or equal to 0. And so now I see I just have half of this graph. And if I come back and add in my horizontal line here, I see now I'm past the horizontal line test because I'm only touching the purple graph at one point everywhere up and down this graph. So we're going to be looking at inverses of functions that have some kind of restriction like this. So let's do an example. Here I've got f of x is equal to x squared minus 7 with the restriction that x has to be greater than or equal to 0. So what I'm going to do is let's go ahead and just plug this in to Desmos. So I'm going to say f of x is equal to x squared minus 7. Okay? And then to add in the restriction, I'm going to do my squiggly bracket and say x is greater than or equal to 0. So I'm going to change this graph to blue. And I see I have basically half of a parabola here. So we're going to find the inverse of just this half. So let's do that. And we're going through this basically the same way we would just any other function. First we're going to switch our x and y. So I know f of x is the same as y. So I have x equals y squared minus 7. And now what I need to do is solve for y. So I'm going to add 7. So I get x plus 7 is equal to y squared. And we talked about in the last lesson how an exponent and a root cancel each other out. So since I have this y squared here, I need to add in a square root on both sides so that the square and the square root can cancel each other out. So now that I have y by itself, I can replace it with my inverse notation like this. And I'm going to say the square root of x plus 7. But now when I take the square root of something, what I need to do is I need to say this is actually the positive or the negative of the square root of x plus 7. Now why am I adding in this plus or minus sign? I'm going to come over here and we're going to talk about it. So let's say I had something like the square root of 4. Okay, the square root of 4, we can say we're thinking of what two numbers, what number squared can get me to 4. Well, I know that 2 squared, 2 times 2, is 4, but also negative 2 squared, negative 2 times negative 2, also gets me to positive 4. Okay, so the square root of 4 can be positive 2 or it can be negative 2. So the square root of 4 we're going to write as positive or negative 2. And so anytime that I'm adding in this square root, I need to add the positive and the negative value. And so now what we're going to do with step 5 is figure out, do I want the positive or do I want the negative? And so just like we did when we switched our x and y, We're doing the same thing now with our domain and range. So here, the domain of this was x is greater than or equal to 0. But now we want the range, okay, if we switch our x is domain. So now we want to find the range that has y greater than or equal to 0. So we need to figure out of these two graphs, which one has this range. So I'm going to go back to Desmos now, and we're going to look at this. And I'm going to add back in my y equals x line, because that's important for our inverses. And so what I'm going to do is I'm going to type in both functions that I found. So the first one, we said it could be the positive square root of x plus 7, or it could be the negative value of the square root of x plus 7. Okay? So now I basically get this sideways parabola here, which is the same thing that we would get if we cut out here. We have a parabola, and so turned on its side, it would be sideways. But we know with this blue graph, we're only dealing with the right half of it. And so I need to look at my two graphs here and say, which one of these has the range y is greater than or equal to 0. So here is y equals 0, right? And I see that this green graph, everything is above 0, but this purple graph, everything is below 0. So if I want everything that's above 0, I need to take the positive version in this case. And if I go ahead and add back my other two pieces here, so this is my the blue graph, the question that we had, and the green graph, I can see that it meets my three characteristics of inverses, right? If I take this blue and I reflect it over the red line, I'm going to get the green. They intersect on the y equals x line, and I still change my x and my y values. See, I just switched my x and y's around. So these two are inverses. So back in the notes now, we can say that my final answer is, is the inverse of f of x is the positive version of x plus 7, because that has the correct range with it. Okay, let's do one more example to kind of solidify this. So this time I've got f of x is 3x squared with the restriction x is less than or equal to 0. So let's see what this looks like in Desmos. So I'll clear this stuff out, but I'll keep my line hidden for now. So I've got f of x is equal to 3x squared. So I get another parabola here. And now my restriction is x is less than or equal to 0. So I'm just looking at the left half here. So let's go ahead and find the inverse by switching my x and y. So I'm going to say x equals 3y squared. And now I'm going to solve for y. And I'm going to divide by 3. So I've got x over 3 is equal to y squared. And now to cancel out the squared, all I need to do is take the square root. And I'm going to take the square root of that whole fraction. And so now I end up with the inverse of f of x is going to be the positive or the negative version of the square root of x divided by 3. And now we want to find the range with y is less than or equal to 0, because I'm just switching my x and y again, I'm switching my domain and range. So let's try this in Desmos now. What I'm going to do is I'll type in both of my equations that I found. So I have y equals the positive version of the square root of x divided by 3, and my y could be equal to the negative version of the square root of x divided by 3. And so I typed in y here because I'm looking for my range where y is greater than or equal to 0. And I can do that by just looking at the graphs and seeing which one has all the y values less than 0 here. Or if you want to double check, what you could do is apply the same restriction. So I can say my y is less than or equal to 0. When I do that, I see that the green graph disappears. But when I do that here, I still get the purple graph. And so what this is telling us is that no part of my green graph here has a range that is less than or equal to 0. So the inverse that I'm looking for is actually the negative version of the square root of x divided by 3. So I'm going to go ahead and close this out. And if I add my other two pieces back in, I see that these are reflected over the y equals x line. They do intersect on the y equals x line. And if I find any point, I can see that its opposite is on the other graph. So these two are inverses. So to write that down back in the notes, we can say that our final answer is the inverse of f of x is the negative square root of x divided by 3. So when functions do not pass the horizontal line test, how does a domain restriction help find the inverse function? Well, when we are dealing with quadratics and square root functions, we kind of end up with two different graphs that we could have for the square root because we could be taking the positive or the negative value of it. And so the horizontal line test will help us focus our attention on half of that parabola. And then we can see, using range restrictions, which range matches the inverse of our domain. So I hope you had as much fun as I did looking at these inverse functions with domain restrictions. Good luck in your practice, and I'll see you in the next video.